Okay, hello everyone. We are Group 18. I am Ziad,
I'm Alejandro.
and we are presenting Wild Sight.
So, in the most basic terms possible, we want to make a drone. Um, we're making a wireless drone that streams video to a website and is controlled over Wi-Fi. We're going to use like a camera sensor similar to the one from E326 that's going to stream video to a website that you can look at on your computer. Um, for flight stabilization, because drones are by nature very finicky on their own, we're going to use some kind of sensor that has a gyroscope, accelerometer, and magnetometer to send data through our ESP32 through SPY that basically gives us input on what we should do with our motors. And the way we're going to control our drone is through a PID loop algorithm that's going to take that input from the IMU, gyroscope, and all those sensors and convert it to motor commands. Um, so for our drone so far, we made a few design choices. The first are the motors. So we picked like these tiny 8520 DC bus motors that are unidirectional. Um, they're very small, lightweight, have decent enough power. They're they offer like about 45,000 RPM and only draw about 200 milliamps of current each, so they shouldn't be too power consuming. We chose brush motors instead of brushless because they're cheaper and they're also easier to drive, which is why, as a consequence, for our motor drivers right now, for initial testing at least, we're using like these MOSFET drivers that have a transistor that you control at the gate through PWM signals, that basically drive the motor, along with like a little flyback diode for circuit protection to prevent any kind of voltage spikes.
Okay, and for the controller or like the website where the user can see the image that's coming out from the drone and control the drone, we will be using the Tornado server that uses a WebSocket and buttons so that we can send the data or like the commands movements to the ESP32. We are hosting the that server on Amazon Web Service the same way we did it in class. And as you can see here as an example, we already created this, and it's sending like to the ESP32 up, your left, your right, down, forward, uh, left, right, backward. So these are the kind of the messages that the server is sending to the ESP32 when the user presses the buttons on the controller. For the sensor, we picked the LSM chip. It's more modern than like the usual MPU 6050, and it has like a 9 degree of freedom. So it has a gyroscope, an accelerometer, and a magnetometer. So we will be using these data to like make sure like our drone is stable and use that in the PID control to um, modify the parameters we are using for the basic movements for the drone. Also, one thing that chip is using SPI communication or I squared C. We probably will be using SPI because it's faster. Even though like it's a full duplex, we won't really need a full duplex, but um, we just thought we can use it since it's an option and it will be faster than I squared C. So that's what we'll be using.
Um, so in terms of the design progress so far, you can see that our Gantt chart right here says different milestones. So we want to like by the end of the second milestone, we want to test the controller code with our motors. We want to research and order batteries this weekend. We want to start making like an initial frame prototype as soon as possible. So probably starting tomorrow on Saturday. And then we also want to finish setting up the ESP32 camera module. So we have like some kind of video streaming on the website, even if our final PCB or project isn't done. And then in terms of our bills of materials, we just really have the motors, um, some transistors, diodes, and then the gyroscope so far. And that's pretty much it. In terms of like overall progress, we were able to like test our website commands with our motors. So we were able to like press the up key and down key and make the motor like spin up and spin down, which was really cool.
Okay, so for market research, the people we're targeting are mainly like early stage drone users, like students, maybe like or like especially focusing on students, educators, um, young professionals who like basically need a simple, affordable drone for learning, content creation, or experimentation. So we're thinking of like having our code to be like open source at the end, and having the user actually be able to communicate with the ESP32. So having like exposed pins. So like if the user wants to add more sensors, try them out, uh, modify the code the way they want. So that's basically what we're doing. So like people who have like interest in like building stuff and things like this. The market size for the hobby drone is about like 4.41 billion in 2024, and it's projected to reach 10.5 by 2032. We have identified two competitors. One of them is like Tello EDU. So they basically make drones and have the software where user can uh, program or like change the drone software using like block coding. Um, so that was actually very interesting. And basically like we have like the pilot-based DIY kits. So or like basically like any um, DIY kits for building the drones. I would say like this is considered to be like one of the competitors to
Yeah.
us.
And we were also unable to interview people for, for this project so far, but we are planning to in the future, especially somebody like Professor Sahakian that knows a lot about electronics because ideally we want to have like some kind of battery protection circuit and some sensor that like tells us how much battery we have left. So we still need to research a bit more about that. And
Yeah, and in terms of like learning and useful information for the learning, we're using the web server, and like we're basically using it the same way we did it in class. So we're having a Tornado server that's listening to clients on a specific port. And it's basically once the client is connected and the user presses a button, basically send that message to the ESP32. Um, and we are actually hosting that controller on the Amazon Web Service. So basically nothing new to that, like similar to the way we did a demo in class.
Mhm. We also learned about something called the ESP32 cam, which is like an addition to the ESP32 that essentially like does the entire project we did in E326 by itself. All you really need is like code for it, which is actually provided in like the Arduino library for the ESP32. So if you like go to like the examples that they have, there should be example code that makes it work. And once you plug it in, you should be able to like see video streaming on a website. Um, and then in terms of useful information, when I was programming the ESP32 and the ESP32 cam, I found that in order to like program it with a USB connection, all you need are like the USART cables of RX and TX. And then to set it to download mode without like any external buttons, all you need to do is just like set the IO pin to ground and then press the reset button, and that should be all you need.
Yeah, and also something that was actually initially in our approach that we were planning to use Bluetooth and create an app using React Native, since it basically creates the app for Android and iOS without needing to develop it specifically for a specific system. However, we found a lot of issues in accessing the Bluetooth and in the devices. So, for example, for the classic Bluetooth, iOS does not allow anyone to use the classic Bluetooth of their device. Um, and so after that, we try to switch to BLE or Bluetooth low energy. Um, and iOS allows you to use it, but you have like it has some restrictions, and like you have to ask the user for their access. Um, and something that was interesting that you actually have to do it using an like a Mac OS machine to make it easy. Otherwise, like you have to like do like tons of steps to be able to gain that access. And like you also have to make like an Apple developer account. So it's kind of complicated. So that's why we decided to switch to the web server approach. And I think it worked pretty well. And like we're able to receive like a streamline of like or like continuous data from the user inputs very quickly on the ESP32.
And then finally, some questions for you guys. We obviously said that we want our drone to be customizable. So like one of the questions we have is what are some other things that we can add to the drone in terms of like sensors or just like external additions? Like for example, some kind of microphone for voice detection if we ever want to do that in the future. And then what would be like an ideal battery life for a drone? Because the main thing is batteries with like a better battery life tend to be heavier. And we want our drone to be as light as possible. So that's something we really have to balance. Yeah. And that's
Yeah.
our presentation.
Yeah. Thank you.